Namaskar, welcome to the channel Anka Anandaharan, that is extracting happiness from the teaching learning process of mathematics. Here, today we are going to discuss about triangular factors and row exchange operations, and also some of the aspects and applications of elementary row operations. So before starting it, just we will have a discussion about what do we mean by a lower triangular matrix. A lower triangular matrix means a matrix, a square matrix in which all the elements above the main diagonal are 0. And what is an upper triangular matrix? A matrix in which all elements below the main diagonal are 0. So this is a condition, that is aij equal to 0 for all I less than j. So here it is upper triangular, aij equal to 0 for all I greater than j. Similarly here, diagonal matrix means all the non-diagonal elements are 0. Whether the diagonal elements can take 0 value or not? Yes, diagonal elements may take 0 value or it may not take 0 value. No restrictions are there on the diagonal elements. Now, there are several methods of solving a system of equation. Most of the cases, a real life problem is converted into a linear problem with this linear equations, several linear equations and several linear unknowns defined on it. And writing that system of equation as ax is equal to b. So there are several methods to solve it. One of the method is triangular factorization. Suppose I have A is equal to LU. Let. That means what? That means I can get LUX is equal to B. So here UX, U is a matrix, X is a vector. Let UX is again unknown because X is unknown. UX. Let UX is equal to Y. So here U is a matrix, X is a vector, I will get another vector. So now what we will get? So substituting the value of Ux, L into Y is equal to B. So from this equation, first we will find out Y. Then we will solve the second equation, that is Ux is equal to Y. And we will get our X value. X is equal to how much we will get. Let us discuss it a little bit more in detail. Suppose my L is equal to 100, A 10, A1, A2, A3, 1 into U is A4, A5, A6, A7, A8, A9. This, it is L into U. So here, then what will happen? So here AX is equal to B implies LUX is equal to this into X1, X2, X3 is equal to B1, B2, B3. So here what we have to do? This is my L matrix, this is my U matrix, this is my X vector, this is my B vector. Okay, so let Ux is equal to Y. Then L, this implies Ly is equal to B. Now from the equation, how it looks? 100, A1, 10, A2, A3, 1 into y1, y2, y3 is equal to b1, b2, b3. So clearly one can observe very comfortably we can find out y1. So here when we multiply, the first equation gives me y1 is equal to b1 and second equation gives me a1 y1 plus y2 is equal to b2. So what about y2? From here I will get y2 is equal to b2 minus a1 b1. Similarly, third equation is a2 y1 plus a3 y2 plus y3 is equal to b3. From here, what I will get? y3 is equal to b3 minus a3 into b2 minus a1 b1 minus a2 b1. So I got my y3. Finally, I got my y1, y2, y3 very comfortably. Now what I will do? My ux. Now I got my y1, y2, y3. So now my next equation is ux is equal to y. This I will solve. So what it is? What is my u? a4, a5, a6. So a4, a5, a6, a7, a8, a9, 1, 0, 0, 0 whole into x1, x2, x3. From here, this is equal to y1, y2, y3. So what we observe? Directly from the last equation, we get x3 is equal to y3 by a6. Similarly, from this equation, from the second equation, a5x2 plus a9x3 is equal to y2. From here, we will get x2. And similarly, from the first equation, directly we will get a4x1 plus a7x2 plus a8x3 is equal to y1. Here this value is with us, this value is with us, substituting which we will get our this value. So here one can observe that we have not done any calculation. Simply one forward substitution, another followed by backward substitution gave us the answer. So it consumes less CPU space, less CPU time. So LU, LDV factorizations are being done. So it is total purpose. So now solving this system of equation, we will get our x1, x2, x3, which is our solution x. So this is one of the method of solving a system of equation. Next is how to find out this LU factorization. Steps for LU factorization. What we will do here? Consider the matrix A, apply elementary row operations R2 minus K R1 stored in R2 to get a matrix. So what we will do individually, we will have three operations defined on it. How it is? My A has 1, 2, 3, 4, 5, 6, 7, 8, 9. First I will make 0 using elementary matrix E to 1. Then I will make it 0 using elementary matrix E3 1. Then I will make this 0 using elementary matrix E3 2 on A to get an upper triangular matrix. Now, what about A then? A is equal to one lower triangular matrix U, which is equal to E3 2, E3 1, E2 1 inverse U. That can also be written as E2 1 inverse, E3 1 inverse, E3 2 inverse into U. This is nothing but a lower triangular matrix. It is my L. So what I will do? I will apply elementary row operations on A to get upper triangular matrix. Then I will take the product of inverses of the elementary matrices in the reverse order. So here first we have done E2 1, here first we will do E3 2, then E3 1, then E2 1 inverse. So I got my L, I got my U, I will write here, I'll get my LU factorization. So next is A is equal to L D V factorization. So here A is equal to LU factorization or LDV factorization. So here what we will do? This L is same as this L. Then I will write U is equal to D into V. So here what is our U? We have considered A4, A5, A6, 0, 0, 0, A7, A8, A9. This is my U matrix. This U matrix can be written as a product of two matrices. One is diagonal matrix. What it is? A4, A5, A6. This side it is 0 and this side also it is 0. So I got a diagonal matrix. Diagonal matrix in multiplied with this is my D. Now I want to write down V. What I will do? I will divide my first row by the first pivot, second row by second pivot, third row by third pivot. Resultant matrix is an upper triangular matrix that will play the role of V. So how much it is? 1, A7 by A4, A8 by A4. Similarly, 0, it is 1, it is A9, it is A9 by A5. It is 0, 0, 1. So clearly it is an upper triangular matrix. So whose name we will give it as V. So I have U is equal to dV and L remains same for both the matrix. So what is LDV factorization? How to get LDV factorization? A is equal to L, which is the product of the inverse of E21, E31, E32, whichever is necessary to get A converted into an upper triangular matrix U. So already I have my L, I have my D, and I have my V. So this is all about LDV factorization. Sometimes one of the pivot position of our matrix, such as 0, 1, 1, 1, 1, 2, 1, 3, 1, suppose it is my A. So naturally the first pivot position is having 0 here. So immediately I will go for permutation of the matrix P on A. What I will do? I will write it as, this is similar to PA is equal to, how much it is? 1, 1, 2, 0, 1, 1, 1, 3, 1. So this is what operation I have done. R1 minus R1 interchange with R2. So now I have this matrix. Then what I will do? Now already this position is 0. So these two positions I will make 0. And I will get my L from, so in this case my L will be E31 inverse, E32 inverse. And in this case, what will be my upper triangular matrix? I will find out it from there using elementary row operations. Once we got, so let us do it to have some idea what we will do here. R3 minus R1 stored in R3, 1, 1, 2, 0, 1, 1, 0, 2, minus 1. Now that is R3 minus 2, R2 stored in R3. 1, 1, 2, 0, 1, 1, 0, 0, minus 3. So I got my matrix. It is an upper triangular matrix. So its name is U, or it is equal to U. So I got my U. What is my L? L is equal to E 31 inverse E 32 inverse. So how much it is? 31 inverse 1 0 0 0 1 0. It is minus 1 0 1. And 1 0 0 0 1 0 0 minus 2 1. So this is my, here this is my E31, it is my E32. Their inverse is, this is plus here, this is plus here, and the answer is 1 0 0 1 0 1. It remains same for all the situations, and here 0 in both case, and this is 1, this is 1. So I got my L. Already I have my U. So what is my LU factorization? In this case, A is equal to LU. What is my L? 1 0 0 0 1 0 1 1 1. This is my L. And what is my U? 1 1 2 0 1 1 0 1. What is the U? 0 1 1 0 0 minus 3. 0 1 1 0 0 minus 3. So this is all about, this is my L, this is my U. Now suppose I want to write it as L D V. L remains same, there is no change at all. For every case, it is my L. And what is my D? Diagonal elements 1, 1, minus 3, 0, 0, 0, 0, 0, 0. This is diagonal, it is L, it is D, then B. In the upper triangular matrix, divide each row by the corresponding pivot. So in the first case, the pivot is 1, second case, pivot is 1, third case, minus 3. So first row will be divided 1, so it remains same. Second row is also divided 1, that's why it remains same. Then third row is divided by minus 3, that's why it is also 1. So this is my LDV. Okay, so with this we got some idea regarding LU LDV factorization.